All right, everybody, welcome to another expert interview. My name is Dave Cooper, and today we have another wonderful show. We are still hanging out in Red Bay, Alabama, and we're going to be here the rest of the week, but that is not going to stop us from bringing you the best in the industry. So today is going to be a lot of fun as we are heading all the way to Denver, Colorado, and to California with our guests that are going to be on the show today, which is going to be great. And not only great, we're going to not only talk about what we are doing in this country, but we're going to talk about what's happening overseas as well. And is there something that we can learn from them? I'd be willing to bet there is. So with that said, at Dave Cooper Live, we are bringing you the people and the processes that are building it better. Our guests and topics include experts in building systems, building science, building codes, and the tech used to build it better. And today is no different. We are seeking out the best and the brightest in construction and discovering all the ways that innovative buildings come to life. And with that said, we're going to spend a little bit of time on some building science today, what the government is looking at doing, and we're going to bring the people that are behind the programs that are making this all happen. So without further ado, why don't we jump into this? So let me bring him in. First up is Shanti Pless from Nrel. Shanti, thanks for joining us. And we have Anchor. Hey, Anchor Potter, glad you could join us. Anchor's a regular, joins the show in the background quite often. And we have Lucas Tripoli. Lucas is also with us. So Anchor and Shanti are from Nrel, and Lucas is from RMI. How you guys doing?
Doing great, Dave. Thanks for having us on the show today.
Yeah, well, love that you guys are here. So let me get my face up here so I can see better. All right. Listen, guys, this is going to be a lot of fun. We're going to have a lot of fun on this show. But before we get started, each one of you has to tell us a little bit about yourself. So you're only going to have 2 to 3 minutes to do it. We want to know everything about you from the moment you were born to this very moment in time. And don't leave out any of the good stuff from the hospital. Shanti, you're going to go.
Everyone knows that, right?
Oh, it's Red Sox time. I hear.
Yeah. So, background. I'm an energy efficiency researcher at Nrel. Been there 20 years or so. Grew up back in Massachusetts originally. My dad was a builder. He had a company in Western Massachusetts called Rainbow Builders. I spent summer colleges doing framing, built lots of chimneys, right? Tearing apart old barns to reclaim, 100, 200-year-old wood, right? And so I've always been in the construction industry. Actually was a framer, moved out to Colorado and was a framer for a year to pay for my grad school at CU in Boulder. And so then got an internship at Nrel back in 1999 and I kind of bringing my construction background with mechanical engineering, building science together to be able to now work on zero energy buildings and productivity and construction. So thanks for having me. Looking forward to it.
Yeah. Well, hey, listen, no, thanks for being on the show. That's more important. All right, let's go around. We're going to stick with Nrel, then we're going to go to RMI, and then Lucas is going to kick off our presentation today. All right, Ankar, let's hear it.
Great. Hi. Yeah, thanks for having me. So let's see. I was born and raised in the islands of India. It's that island life or that experience, kind of like childhood experience of growing up in an island kind of like taught me a lot of things, especially like disaster resiliency and things like that. Was there in the islands when the tsunami happened back in 2004 and all like issues with resilience that went down there. And so kind of like those things inspired me from childhood, and then like generally looking at like seismic buildings and all of that like made me like launch myself into like architecture school in India. Did my undergrad there, more of like traditional architecture, but then got really interested in the technologies like manufacturing technologies that can kind of help deliver buildings, better buildings in the future. And so got involved in India and then in Tokyo in more of the generative design, computational design side, but always like sticking to the building industry. And then came here to US for my grad school at MIT, where did a bunch of research on digital fabrication, was in the mix of these manufacturing tools and design automation tools, if you may, that are slowly emerging in the practicing architectural industry. Here at Nrel for 1.5 years now, working closely with Shanti on a long range of projects, but mostly focused on how to modernize the construction industry and also to help them integrate more energy efficient strategies that we'll talk about later. But thanks for having me.
Yeah, no, love it, love it. All right, Lucas, we saved the best for last. Come on, hop in there. Let's hear everything about you and get into it.
Hey, Dave, thanks again for having us. And it's my pleasure to join the colleagues from Nrel here. Thanks to Shanti and Anchor as well for inviting me. So my background is pretty varied. I'm also from Massachusetts, like Shanti, and I grew up spending time between the US and a bit of time in Europe, which is where most of my family is from. So that got me kind of interested in all different kinds of buildings and architecture. I ended up doing architectural history in undergrad because they didn't have a pure architecture program where I went. So I came at it a little more from the humanities side, which was still pretty interesting. But my on-campus job was working for the building managers of one of the largest buildings on campus. So that got me kind of more into the world of building systems and building management. And following that, I worked a bit in consulting and then ended up in the real estate development world. So more kind of from the owner's side, owner's rep side, and working on different kinds of construction management, operational management, but always with a focus on energy efficiency and renewables, and thinking about how can we make buildings better. Following that, I ended up in grad school here on the West Coast. And from there, I ended up at RMI, where I'm working on essentially decarbonizing the built environment with the carbon-free buildings program at RMI. I'm the project lead for the Advanced Building Construction Collaborative effort that is in partnership with DOE. And so I'll tell you all a little more about that today, and looking forward to the show.
Yeah, awesome, awesome, awesome. All right, guys, we're looking forward to it as well. So, Lucas, we all decided before the show that you're going to start us off here because it's going to lead into a much broader conversation. So, before we do that, I know we have a video. In fact, we have two videos today, and we have a bit of a presentation that Shanti's going to give as well. Talk to us a little bit about what is happening overseas and some of the things that you're working on. We're excited to hear this.
Sure. Yeah, so what we're working on, as I mentioned, is the Advanced Building Construction, or ABC, effort. And that's, in a way, the conceptual successor of a program called Energy Sprong that's going on in Europe. It started in the Netherlands, and now it's expanding into several other countries there. The idea behind Energy Sprong, which is focused primarily on housing, is to take inefficient housing stock in the Netherlands and other countries in Europe, and to come up with a fairly standardized and streamlined approach to retrofitting that housing so that it's more comfortable and also more energy efficient. So I'll show a short video here that's kind of a fun look at the approach that they take there, and then I'll tell you a little more about it and how it ties into what we're doing here.
Great.
This is made possible by the use of new technologies such as prefabricated facades, new smart heating and cooling installations, and insulated rooftops equipped with solar panels. People don't even have to leave their homes because the transformation is completed within 1 week. After a net zero energy makeover, the house looks bright and modern from the outside and no longer has moisture or drafts inside. This makeover comes with a 30-year warranty on both the energy and indoor climate performance.
So that's a little bit of a, kind of fun animation, but it gives you the idea. A couple of important learnings from Energy Sprong here. One is this idea of a streamlined approach that is not disruptive to the lives of the occupants. So in many cases, the Energy Sprong projects are done on occupied homes, and they can be done, as the video said, with the occupant actually even being in the home or maybe while they're at work, because the on-site work is very streamlined. It's very short. That's achieved by doing a lot of pre-work through some precise scanning of as-built conditions, and then having a lot of the work moved off-site into more kind of controlled manufacturing style facilities where they make unitized systems for mechanical as well as envelope, and then deliver those onto the site and install them. I think another learning from Energy Sprong is the idea that beyond energy efficiency, there's a lot of other co-benefits from this kind of work. One of them is comfort, and that's a huge one that's seen in homes, because when you have a tighter envelope, you don't have drafts, you don't have these pockets of hot and cool areas in your home, and you don't have issues with moisture or mold. You have better indoor air quality. I think something that I would change about this video is that it makes it look like it's this little, robot that comes in and does it. And I just want to pause there and say, that's not really how it works. There are still a lot of people involved here. There's still a lot of jobs involved here. And I wouldn't want anyone to take away from this that, what we're doing here is to make this little round robot that then, replaces all of the good folks working in construction today. In fact, as we'll get into a little later, in my eyes, there's an opportunity for more rather than fewer jobs in the construction industry with everything that we need to do, even if we're able to make some of the significant productivity gains that we're working on and that the folks at Nrel are researching as well. I think two other learnings from Energy Sprong. One is the idea of this consistent approach, this idea of relatively standardized parts that can be adapted to different kinds of housing, but that you get some economies of scale. And then finally, the idea of streamlining financing. And that's something that in the Netherlands, they had the benefit of having strong government support and having a sort of package approach to the financing for these projects that allowed the net cost to the occupants or the owners of the house to essentially not change, or actually sometimes reduce their cost of living even with these upgraded houses. And that's something that with the ABC Collaborative that I'm working on here in the US, something that we're going to be looking at in terms of how do we come up with packaged approaches to make it easier for ABC projects to get deployed in the US.
So my questions on this right away. One is the Energy Sprong program is already in place, and if I saw correctly, there's already 5,000 homes or buildings have been modified or retrofitted already. Is that correct?
Yep.
Yep. And I know you guys are probably going to jump into all this, so tell me if I'm overstepping my bounds already. But the other thing is on that is that a Tesla vehicle driving all those systems? I mean, it must be a big vehicle to pull it out, but it's pretty cool. So you guys are looking at retrofitting buildings that people are living in with minimal disruption to the occupants in the building to reduce the consumption on the grid and to make it more affordable for people to live. Is that a good summary of what we're doing here?
Yeah, I think there's even more co-benefits beyond that, but that's a great in a nutshell, Dave. Thanks.
And Dave, the term industrialized construction you hear a lot, where the process becomes more of an industrialized, repeated process, and the way you go about it, you're looking for those things that you can repeat and get better at as you go, so that you're getting it faster and cheaper as you do more. So you're scaling it, you're industrializing it. And so there's a lot of process improvements that have to happen, a lot of products that have to be developed that lend themselves to that industrialized process that takes a lot of research and a lot of demonstration and a lot of effort to really to kind of move beyond one-off building retrofits.
Yeah, right. Well, I mean, really, it's the cost savings on the energy side that should start paying for the retrofits, right? I mean, is that the balance?
Yeah, so that's the idea in the long term. Some of the approaches that we're looking at now, because they're fairly developmental, they have higher kind of startup costs. And that's the research that Nrel is doing and the kind of market approach that the ABC Collaborative is working on. Both of those are aimed in part at bringing down those first costs by coming up with more efficient manufacturing approaches with, as Shanti said, demonstrations and pilots that eventually lead to scale and economies of scale. So, in the U.S., we've had a couple of pilots. There was, one at Castle Square in Boston that was done something like 8 years ago, I think. That was, not really industrialized, but it was this idea of a large scale multifamily deep energy retrofit. That one provided a whole lot of cost savings, but it required some funding support from a number of different state, local, and federal entities to kind of make the numbers pencil out. I think what's important to consider here, though, is that beyond the energy savings of your utility bill, there are a lot of additional value streams that potentially can come from making buildings better. There's comfort, of course, which is sometimes it's hard to put a price on that. There's health, which the healthcare industry has done a very good job of putting a price on. And if you go look at some of the data tables from health insurance companies that they have behind the scenes, they can tell you what the savings from an avoided asthma attack or less treatment for pulmonary disorders are, things like that, and improved indoor quality and to some extent improved comfort can drive those positive health outcomes. So we really see a lot of benefits across the board in what we're doing. And when I talked about streamlining the financing, I think part of that is getting banks and other investors and underwriters to recognize and capture some of the other benefits and value that better buildings bring to the table.
Yeah, I would imagine so. So, all right. One of the things we've been hearing a lot of is how unhealthy homes can be. Like you were talking about, there's a lot of health issues that people don't realize are being caused by their home, their migraine headaches, their asthma. All of these things might be just able to be resolved if they just understood their home better. And I think that's a huge, that's a big thing across this country to solve, right? I mean, that's a huge undertaking if you think about all the buildings and retrofitting and making them healthier. So how did RMI and Nrel come together? Like, where did this collaboration kind of like, they said, all right, well, we like what you're doing, we're going to work with you. How did this all start seeming together to where we're on this show today?
I think DOE, Department of Energy, can take a lot of credit here. I think the good folks, especially in the Buildings Technologies Office, have done a good job of listening to advice from Energy Sprong, from RMI, from others, as well as great ideas coming from within BTO. And that has driven the creation of this Advanced Building Construction Initiative that's kind of the umbrella program run by BTO. And within that, or connected to that, there's the ABC Collaborative that RMI is running, as well as a lot of research and analysis that's going on at Nrel and the other national labs. But I also don't want to minimize, the great work that the national labs have been doing for many years, even, before the ABC initiative was set up. I think that what ABC has done, what the DOE ABC program has done, is create sort of a place where we can find each other and work together. And the collaborative is sort of a market-facing outgrowth of that. So, I think the DOE is kind of the answer to your question, Dave. Okay. But it's also just when you have a lot of folks who are working on making the world, I like to think, a better place, but especially making buildings better. They tend to go out and find each other and find who's doing interesting things that can build off of each other. So I don't know, Shanti and Ankur, feel free to disagree, but that's how I see it.
Yeah, I think Ankur and I work in a program called Communities and Urban Sciences, right? And so we try and develop new technologies, do a lot of new modeling, new approaches to thinking about energy efficiency and, in this case, productivity. And so and when you have folks, nonprofits like RMI, the RM used to be the Rocky Mountains, right? And Nrel being co-located here out in Colorado. We worked on similar projects together where we could bring some new technologies and approaches to some of the scaling efforts and the market work that they were doing. So we definitely have a long-term collaborative relationship over the years as well. And then Dave, your other question, I think you kind of mixed two questions there, was about indoor air quality, right? And kind of scaling. And there's some comments in the in the comment section here about radon, and when you seal up these buildings, what do you have to worry about, right? You can't just do super airtight retrofits, right, without having to think about how you're now ventilating, right? We're not using the leaks in our walls anymore for unfiltered, uncontrolled ventilation. We're controlling it and filtering it, and so as part of all these energy sprung type whole home or whole building retrofits, and so the controlled mechanical ventilation and with the energy recovery devices ends up being the key strategy that comes along with an air tightness retrofit that is critical. That will keep you filtered fresh air, controlled, right? What's the saying, Lucas, is
build tight, ventilate right.
Ventilate right, and so that's what they mean when they talk about that, is that it's a combination of those two. And the other, and it's not just radon, right? It's moisture management now, right? And that or if you haven't electrified as part of your retrofit, you've got a lot of combustion in your house now that historically you didn't really worry as much about when you had leaky basements or and so I'm thinking about air quality, moisture management, as well as radon. Things like radon are all part of how to do it efficiently and with health issues in mind.
Yeah, for sure. And so, hey, since you brought up the comments, Shanti, let's say hi to some folks here in a second. So if you are just joining us, we are live with RMI and Nrel. We are on LinkedIn, YouTube, Facebook, and Twitch. Shanti, why are we on Twitch? Because all the young people are on Twitch.
Well, we own Twitch?
We are, of course, we're on Twitch. That's where the young folks are. And since I know they're not going to come to us, we go to them each time. And we actually have some people joining us from Twitch. So thumbs up to all of you. All right. So let's go and say hi to a couple people. Who do we have joining us today? The Joel Hutchins. What's happening, Joel? Hi, all. Happy Monday. Good to see you. All right. We have Arjit Patra. Did I say that right? Arjit, I think. Patra, thank you for joining us today. And then our question comes from, looks like Damien. Hi, guys. In Ireland, there was a university-led study where retrofitting houses led to radon gas levels doubling in readings due to issues surrounding ventilation. And Shanti, this is what you were talking about, right? As we're building tighter envelopes, now we have to mechanically control the air better and be more efficient about the air in the homes. Is that accurate?
Absolutely. That's I think that's part of it. Yeah, I mean it's even to the point where we're trying now to think about ways to ensure, say, an overclad retrofit solution includes ventilation, either ductwork or equipment, right? As part of the overclad solution, so that it becomes an integrated solution that is required to do both. Yeah, for sure. Love it. And then looks like Damien put a link in there. Anybody interested in hearing about the Irish Times retrofitted homes could double radon? That's that's interesting because it's absolutely true, right? I mean, you lock in the air and not do the proper ventilation, you're going to run into those issues. Look at that. We got Heather Wallace in the house. What's happening, Heather? Good to see you. I hope all is well. Thanks for joining us today. And Arjit said, excited to be here. All right. Let's carry on with this conversation. So ventilation, air tightness, sealing up homes, these are all conversations that I'm very familiar with from our BS Friday show. So diving into how do you make this attainable, right? This is one of the things, right? Because air tightness, okay, great. More ventilation systems, okay, great. All of this adds up to costs and what have you. So part of what you guys are working on is, how do we do this in an efficient way to keep the cost down, to make it available to the mass housing market that's out there? So Shanti, you want to walk us through and anchor what you guys are working on right now to with the Energy Sprung program, with RMI. How are you guys looking at this, and how are we going to change the way the world builds and retrofits homes? That's Dave, the $1 trillion question, right?
I know, but you're a smart guy. I think you got it.
Right. So the way I think about it is every other industry where productivity is doubled, tripled, right? Where the cost of solar panels, right, are down 80% last 8 years. The cost of batteries, the cost of LEDs, wind, right? Everything that has been able to take advantage of industrialization and learning curves around mass. Kind of the more you do, the better, the cheaper it gets. Concepts. is seeing significant first cost reductions in their energy solutions, all except for construction in particular, and specifically deep energy retrofits, where the construction cost inflation we see in the construction industry is also tied to what it costs to save energy. And year over year, it gets more and more expensive, right? And we're going the opposite direction, whereas if you think about the other alternative solutions, which are all great, right? They're all kind of low carbon off, no carbon renewables and such, are continuing to get cheaper, right, and more viable. And so, our goal has been to think about how those industries have reduced those cost curves and apply them to retrofits and construction. And so that's at a high level, I think, the concept we're really taking and trying to apply. And so maybe Encore, you have thoughts? It's been Lucas and I here. I think your experience in kind of some of the design side and kind of industrialized construction, you might want to jump in a little bit about, or even some of the tools that you see are being kind of investigated that could help lower those kind of one-off, high kind of unrepeatable solutions.
Yeah, sure. Yeah, I can jump in. So, traditionally, like my background with in architecture kind of exposed to like a lot of different digital tools, like in the design side, but also like in the other subsequent construction phase and following them. But too many tools to work with, and sometimes you are kind of like at the mercy of the tools that you have. And so, so there's definitely an opportunity where when your method is different, and when you're trying to think through some of these the tools that manufacturing industry has been using for a while, like digital twins and process modeling platforms, and things like just an integrated productization approach. That's something that is emerging in the building industry, but still we are building one-offs, right? Like it changes from project to project and depends on the kind of software tools or the skill sets that you come with. And so a part of our work at Nrel is to really look into these tools that other industries, especially manufacturing industry, has been kind of like been using for a while now. And that it kind of enables this approach to move from one-off projects to products. And in the mix of it, something I would like to add is it's not the translation of these tools are not as simple and as direct as one could imagine. Just it's not as if we can take up an existing tool that is used to develop cars and use it to kind of start designing buildings with. There is a lot of complexities, added complexities that you work with when it comes to the building industry. And there's definitely a need to rethink some of the tools and the approaches that we have. And part of that, something we're kind of interested at Nrel is a principle that we are kind of building on top of. It's called Design for Manufacturing and Assembly. It's pretty overused at this point, and a lot of people, even in the industrialized construction, are talking about it. But if you look at the kind of like work that's out there, Dfma mostly sits into like small gadget-based products, or even like cars, or maybe like even like larger industries like designing and manufacturing aircrafts. But it's almost like buildings sit in this strange like middle ground space where it's with all of its own complexities, where there is an opportunity to rethink how a Dfma approach would work with buildings. And my background and experience with Dfma back in my grad school has been more on, hey, like you look at a structural system of a building or an envelope of a building. Can you, from a Dfma principle, like re-productize it, or kind of like decompose it into smaller parts, and how it will be put together versus a stick-built home? How can it be different? And then you start using certain manufacturing tools like CNC in order to deliver that structural system. However, that's just the structural system, right? And you need to now consider the mechanical system, and you need to now get into other systems of a building which are more centralized, and start thinking about like how can you productize them. That's where the complexity increases, and that's something that at Nrel, Shanti and I are like very interested in kind of dealing with that. Is there an opportunity to look into design for manufacturing and assembly for these mechanical systems and energy efficiency strategies, how they all come together at a whole building system integration level? Again, like with current like tools of like a CAD environment, this is a lot of work, especially like for like to do it all manually. So there is an opportunity, and we'll get into that later when like Shanti talks about more of the more of our work, that this is where generative design comes in. And I know there have been folks on the show, like from Creo Modeler, for example, and Joel is also trying to do some of that with this upcoming platform. But that's where like how do you manage that complexity will be interesting. So there are like two pathways here, right? Either you completely get rid of complexities and go to like, a stripped out, lightweight, almost like a Cybertruck version of a building, right? That's one approach. In order to like get to that stage, like it needs like a lot of like new inventive structural systems and approaches. But then what we are but we'll get there probably. I don't know if that's the right pathway, but at this point, managing the complexity is more important, and managing it efficiently is more important. So you are now at the mercy of certain certain mechanical systems which are centralized. Great, you want to still do that, and you still want to get that in your project, but there's still some opportunity to get into DFMA without going for the ideal futuristic scenario yet.
Yeah, so I mean, this is how do you bring all of this together? We're going to go to some comments, because there are some comments here, and I think I want to talk about like how does this all come together? Because you're right, there are people out there doing bits and pieces, components of all of these things you're talking about, and you guys are looking to say, well, how out in the world do I find all the bits and pieces and streamline them, bring them into a very efficient, very cost-effective way to get to the masses? Would that be a good way of putting it? Like, how can I take it to the masses? But first, I'm going to ask you a couple questions here. So we got Henry Mickelberg has his question. Cynical Henry this time. The retrofit ROI model in Europe is based upon selling carbon credits to the big energy companies to meet their mandatory targets. How might this work in the U.S.?
Yeah, I can take that one to start, and then Shanti and Ankur might have something to add. But I think it's the U.S. is an interesting case because every state is a little different. So there's a couple of different answers to this question. The simplest answer is that in some states, you may see incentive programs or carbon management programs that kind of replicate what's going on in Europe. That's the easiest answer. The more complicated answer, it draws on something I was talking about earlier today, which is the idea of going beyond just a energy savings ROI and looking at kind of a total value model. So I'm thinking again about health outcomes from improved buildings. I'm thinking about resilience outcomes from improved buildings. You have cases of there's a passive development out in Maine that was in the middle of a winter storm and lost grid power. But because of how well they were built, they had what's called passive survivability. They essentially maintained comfort even without power or even without grid power through this very intense storm with extremely cold temperatures. You're going to start to see, in my mind, as we deal with a higher frequency of extreme weather events, you're going to see more value placed on that resilience element as well of better buildings, of more efficient buildings. So health, comfort, resilience, those are three pieces that can be drawn on for additional value to kind of balance out the value proposition. And then, to what Shanti and Ankur have been saying, It's also about bringing down the first costs, and that can be done through modernized methods, industrialized construction, more streamlined, digitized workflows, and Dave, to your point, through collaboration.
Sure. Shanti, Ankur, you have anything you want to add to that? Here's the question again, if you want me to put it up.
Yeah, sure. I mean, I think I work a lot, probably more on the commercial and multifamily side than on the single family, other than my old house here, in my free time. And what I see a lot in especially corporate America, where everyone's got these net zero carbon commitments, that historically people would buy offsite carbon commitments or offsite renewables and kind of say, yeah, we've met our 100% renewables, 100% clean energy goals. But are starting to recognize that I think their customers, the general population in the United States, sees through some of that, and so starts to think about, well, what can we really do that will allow us to meet our 100% renewable goals, right? And those are significant. And when you get large companies behind seriously taking these commitments, they start looking at their existing building stock and say, this is our key opportunity for retrofits, or when we get new leases, to really kind of put our corporate money where our commitments are. And so on the commercial real estate side in particular, we are seeing real action and real kind of results there, where these commitments are being made. And as you get more utilities driving towards 100% renewables, like here in Colorado, our utility here has got a 100% clean energy goal by 2040, I believe, and 80% in the next 10 years. They put a lot of money behind the best way to do that, and that includes things like electrification, retrofits in buildings, and weatherization programs. And so they're incentivized to support this. And so we're trying to the partners that Lucas talked about, both the corporate kind of dollars behind it, as well as the utility dollars that have these commitments, is where we're seeing I think a lot of effort.
Love it. And hey, listen, if you guys are just joining us, we are going to be talking about some of these programs that you have in place and partners and things you're looking for. So don't go anywhere. That's going to come up here later in the show. But you're right. There's a lot of dollars out there researching and going towards this with the government, with local municipalities and all those things. So we're going to hop into that as well. All right, let's move on to the next quick question here so we keep up with everything. Damien asked, does the U.S. have accredited contractors for retrofitting to reduce home carbon footprints? And he talks about Ireland again. It looks like Ireland's taking some pretty big strides here.
Yeah, I would say, again, the environment's a little more fractured here. It depends a bit on the state and the utility area. There's certainly third-party accreditation like LEED or Passive House. And, they'll come in and they'll actually test the product sometimes at the modeling stage, and then also at the kind of commissioning or post-construction phase. In terms of, government or utility approvals, a lot of times there's either a kind of a cost effectiveness requirement to get some utility incentives or some performance-based kind of modeling approvals if you're going through a performance rather than a prescriptive-based approach to design. So I guess the short answer is we don't have something quite as simple as what it sounds like they have in Ireland, but there are some pieces of that in some areas. And I do think that getting more clarity on how to build a building well, and also how to make sure that it's actually built that way, would be one of the drivers to scaling up advanced building construction and high performance construction in general.
Love it. Perfect. Okay, so thanks for the question, Damien. We're going to take one more question, then we're going to move on so we can get through everything that we need to get through. But we are going to answer all of your questions. I see more coming in. But let's, since Ankur, you were talking about Dfma, which is the buzzword, I would say, of 2020 for offsite construction in general, right? Design for manufacture assembly. Let's appease Mr. Joel Hutchins here. Ankur, I'd love to hear your thoughts on Dfma and digital fabrication in relation to productized processes. What efficiencies do you see being driven in the approach throughout a building life cycle? And just so everybody knows, I read these because they don't show up on all the platforms we're on, so that way people knows what you're talking about. All right, go for it.
Sure, yeah. So Yeah, a lot in there, but I'm sure like Joel is aware of this curve that goes around a lot, like this graph called the Mcleany Curve, and it's basically talks about the entire like building or design, pre-design schematic, and the entire life cycle, and then when is the right time to impact what and where does the most opportunity lie, and so. In terms of like, if you just like think of the curve, the Mcleany curve, what it talks about is the early you get to take decisions is the highest opportunity to perform design for manufacturing and assembly. It's basically the pre-design, early design, schematic design phase, right? And so I think like in terms of like Dfma, like when you do any kind of like process thinking, you kind of like have to go through like, okay, what's the process that I'm going to take, or what is the set of tools that I'm going to employ in order to build this building, right? And somewhere the selection of those technologies kind of informs to a great extent how you're going to design. It's just like it's always at the back of your mind, right? As an architect, when you're designing, you know, like, okay, this is going to be like manually built and like stick built. This is how the design is going to. And so it kind of like it feeds each other. And so I think the moment you have committed to use digital fabrication tools, right? Let's start with the simplest, like let's say subtractive manufacturing. Let's start with like a CNC machine, and you have decided that all of my envelope systems are going to be like cut out of a flat stock and CNC machine. Then suddenly once you've committed to that, now you have to start thinking through how do you design it in such a way that your envelope kind of like with all the tolerances involved and how the pieces come together, how the corners are and all of that. And so like a lot of people like start with the design and then like, you know, it cascades into the later stages in the building life cycle. I think there are certain decisions in the Dfma process which needs to be made like at the right, like on the first day of your the first meeting itself, and that kind of like helps you stick to your plan, right, and not pivot again and again, which is like very common in the industry. So yeah, so I think like design for manufacturing and assembly in its truest sense is not getting into design before you have decided on your manufacturing and assembly. So that's how you like would break it down from digital fabrication perspective.
You know, it just surprises me. Every other industry, when you plan your finances, you're always starting with the end in mind. Doesn't it make sense that we do the same thing with what we do?
Yeah. So when you say like with the end in mind, right? Like, so there is this concept of push-pull in manufacturing where so the pull is where you are like pulling from the end stage and like coming back to like, you know, like working your way back. And building industry is push, where you increase complexity in every process without like knowing what are the kinds of complexities in the next. So again, like just going back to also like trying to address Joe's question that the tools that we have as of today are just like the management platforms that we have as of today are not encouraging us to the industry to move towards the direction, fortunately. And so there needs to be kind of like more simpler tools, which informs simpler product in the end.
Love it. All right, perfect. All right, let's get back into our presentation here, guys. So, Shanti, I believe you're up, or Ankar. Who wants to go next? Oh, you're muted, Shanti.
Lucas, were you going to have some more ABC slides? Do we want to do that too, or
hey, whatever you guys want to do.
I've talked a lot, guys. I don't want to steal the stage too much from Nrel. I have a few words to say at the end to wrap us up, but okay. I want to let you guys show some of the great work that you're doing.
Cool. Well, I've been waiting to lots of questions about Dfma and energy efficiency, and so I've been waiting to get into this because both Encore and I have been working for the last couple of years on volumetric modular. So this is a little bit different kind of focus on, the retrofit problem is really difficult. A lot of existing buildings. There's some building types that are similar in certain cities and vintages, but in general, you look across the U.S. and it's a big country, lots of vintages, lots of construction means and methods that are not consistent, like you might see with Energy Sprung. So very hard problem to get to really industrialize, but that's why we're working on it, right? That's what national labs and folks like RMI and DOE are really spending a lot of time thinking about. But there's also an opportunity to have some wins around using volumetric modular new construction, factory-built apartments or hotels, and think about how we can use that process to integrate more energy efficiency by taking advantage of factory-built apartments, right? And so we've been, so let's see, if you wanted to share that slide there, yeah, maybe I'll jump around a little bit, but when you look at, it's, what we're really trying to do is, there we go.
Can you go to full screen mode?
I can.
There it is.
Yeah. So this is there's a question, how do you do this, right? And what does it mean for energy efficiency? And so what it really means is that we are trying to maximize the amount of best-in-class energy efficiency you might see in an apartment, and install that, design it so it can be installed as part of the scope that's in the factory, right? As part of the modular construction process. We're trying to maximize construction energy efficiency scope that can be installed in the factory and remove scope from the site. That is typically expensive, more coordination, and takes longer, right? And so that really means we're trying to unitize, bring as much of that efficiency, those efficiency strategies, to the module, right? And so that means things like centralized HVAC systems on the roof, like this, right? That's not a Dfma solution for volumetric modular, right? Something on the right maybe might be able to be, right? And so that's specifically around this idea of mechanical pods, which are also being considered and thought about and developed for the retrofit market. Energy Sprung, they bolt these things on the side of your facade during your retrofit in new construction, where you could install it as part of a factory solution, eliminate at least the apartment mechanical scope for on-site and put it all into the factory. It means we can take advantage of all the benefits of off-site construction applied to some of our more expensive energy efficiency strategies, so that we can afford things like in-unit ERVs, distributed hot water instead of centralized hot water systems, right? All electric solutions that allow us to do heating and cooling, and minimize all the refrigerant lines that would have to be installed in, say, a VRF system with the rooftop equipment. You open up the rooftop as well. We're seeing a lot of smart apartment control systems going into these apartments. And it's a pretty complicated control integration scope to get your thermostat to talk to your phone, to talk to your access control, your smart locks, and your tenant billing system, right? And that's you can go buy that now. A lot of these property management firms are offering that as a tenant engagement platform. But that's a pretty complex system, and if we can install that, quality control it, make sure it works in the factory, we could take advantage of modular construction benefits for high efficiency controls, and have some expectation that would actually work. Here's the last two here that I think your audience will probably hear a lot about: air tightness and how to get exterior insulation levels of R value within the wood structure, so that you don't have to have exterior insulation. Get an R19 wall within the stud. I think you probably know what I'm talking about there.
Yep, sure.
Yep, right. And so that's a specific Dfma solution, because you can now install the code required or the extra insulation without having site continuous exterior insulation, right? So that's a great example, and got some examples of analysis we've done with some of our factory partners to prove out the time and cost savings by using that specific technology.
And I want to point out, so everybody really understands, at Nrel, you actually have modulars on site. So it's not just research and paper. You have physical structures on site that you are conducting research on and working with other partners and collaborating to pull this information together, correct?
Yeah, right. That's right. So we've got factory partners like this, steel and wood. Let me jump around a little bit here, Dave, so I can get to that slide. So probably, Dave, last time I think we saw you were touring this module here, the white one. That's an IE module, right? As a home innovation tour, I think, at Nrel last year. And so today, touring through kind of one of our experimental apartments. This is our research block, as we call it. Since you were there, another block has shown up. This is a steel frame block from the West Coast from a company called Blockable. We're doing things like, this is just the recent 3D scan we just did of that to look at how we could use 3D scans to manufacture overclad panels, right, as part of a research project that we have underway.
Shanti, just because we haven't really talked about 3D scanning, what is just quick cliff note? What is 3D scanning so people understand it?
It's a point cloud where every single pixel in this scan represents an XYZ point in a CAD file, so that then you can use that to design specific overclad attachments that would go on over top the existing facade. So it can streamline the details of how every facade is different and where you might attach an overclad system if you're to retrofit this wall system.
Great, thank you.
Yep. Encore probably has more technical details than that. That's my basic understanding of it, right? Encore, is that...
I think that's good for now.
Okay. Yeah, so there we are. This unit was one of their early prototypes that our partner Blockable had built. I believe Bill Gates was in this when they had it on at the Microsoft campus. This is one module, and now we've got it to look at things like smart apartment control platforms and how to get their factory process to get pre-certified at a net zero level. And so that they can do the air tightness testing and know high confidence that the modules they're building coming out of their factory are at the net zero energy certified level. Our foundation through the Wells Fargo incubator helps to fund that work. So that's us there during the set or the placement, I guess, at our outdoor research block test facility. Yeah, there you go, Dave.
Warm up.
Let's see. Jump around a little bit here, but that's how we think about DFMA. I think when we first started getting into this industry, the building in the bottom right there is Denver's first volumetric modular apartment project that iUnit had done. We thought it was always, these are all stats you know well, right? And the Modular Building Institute talks a lot about, but no one's really done a deep dive into, well, are they more efficient inherently, right? And from volumetric modular, you would think they were, right? Where moisture doesn't see wood during construction, you get better quality control. But does that really result in more efficient inherent builds? Something Encore and I and our team have been diving into with our partners to really understand how much more efficient is it and how to use DFMA, advanced manufacturing concepts to get all the efficiency strategies we all talk about. That we see in the industry more cost effectively integrated into the offsite manufacturing processes.
So is it more efficient?
It can be. It isn't necessarily, though. So let me see here. So the first one where it really makes the most sense, where it would be more efficient, is in the air tightness, right? And so one of our factory partners at VBC in the Hamlet, North Carolina factory was some of the first air tightness testing we were doing as those those mods were coming off their factory. We were doing blower door tests along with Colby and Momentum, right, to understand what the kind of inherent air tightness is for a build that had no requirements for testing, right? These are they don't have codes or certifications that require after set testing for air tightness. We're getting anywhere between 3 and 5 air changes an hour, and 4 units coming off the factory line. And Encore will talk a little bit more about how we model that factory to understand if we were to get more airtight solutions. You bring the solutions we all use and site construction to this factory. How much extra time would it take? How to use a factory, a station setting to get as an air tightness station. And so brought in one of the leading companies that have been really proven out their sealing solution, right, for site build, and brought them into the factory to figure out how long would it take to set up the prep, how long would it take to actually do the sealing, right, to get from your 5 air changes down to 1 air change, and then how long will it take to clean up after if you've heard about how this technology works, where you pressurize and then spray an aerosol-based sealant in, finds all the cracks and seals them up over time. And
yeah, so everybody understands what I'm going to jump on this because, I mean, it's kind of neat. I know, I even know Volumetric, BBC tried this, or maybe they are using it in some of their modules. But it really is. It's like an aerosol. You set up the tubes inside the building. Correct me if I'm wrong. You turn it on, and like a blower door, it'll actually find its way to all the air leaks that are happening within that building, and I guess coagulate like blood does and clog them up. Right?
That's right. And the tighter it is to start with, the less time you actually have to take. A typical site might take a couple hours to get to clog up. Right. Yeah. It takes maybe 45 minutes per apartment and another 128 minutes for prep to seal to get it ready. And if you can imagine using a manufacturing approach where you actually have a station, the equipment's already set up, you've already got your tools and your blower door and everything ready to go, you can reduce the time it takes by 60%. Is what we found in our in working with VBC and their initial efforts there.
Right. Okay.
That's time and money savings, right? To get down to an ACH of 1. Which is the air tightness levels testing, right? That we're shooting for, which is pretty tight. So that to me is a specific example of DFMA applied to an energy efficiency strategy to take advantage of factory built buildings. Right.
Love it.
Lots of good data that working with them that we're able to really prove out in terms of comparing to site sealed units and how long they take versus what we think we could get to. And when we have an actual station to do this at scale.
Perfect.
So a paper there, you can, if people want to take a look at the details of how all that works and kind of how we're thinking about this. There's a recent paper on Kern and team put together. And this is the website for the greater Advanced Building Construction program that DOE runs, where this past year they selected 40 projects, put in 26 million to 29 different groups to all think about productivity and energy efficiency, new construction and retrofits.
Right.
Yep.
So with all this research, and once you have it all figured out, if you ever figure it out, it's ever changing and ever evolving. But how do you take this information then roll it out? What's the steps with this? Because here you're doing all this research. I think the next step is, all right, now you need the partnerships, the collaboration. How does all of this come together so it's not for naught, as they say, right? That we're actually making gains, we're actually progressing in the right direction. And the fact that the government's looking at it and moving things forward, I think, to me, it's always been like lead the way, right? So how you leading the way?
You go on Dave Cooper Live and tell everyone about it?
That's definitely a good place to start.
That's maybe Lucas, and that's the good question for how the collaborative is intended to work. Right? There's a lot of work happening. It's a national, a national, international opportunity and challenge, and so learning from everyone and accelerating this together is really where it's at.
Absolutely. Yeah. So. Sorry, Dave, were you going to say something?
No, go. Hey, listen, the floor is yours. The screen.
So the ABC collaborative effort that RMI is leading here is that's one of the intents of it is to understand what is needed from industry. What are the gaps, both technical and institutional, help to feed those back into the DOE and national labs and other centers of research so that they can kind of push out solutions and then create a bridge for those solutions to actually make it into the market. And when I'm talking about solutions, I'm talking both about technical research, technical solutions, as well as just the thought leadership, the best practices, having guides that the industry can actually follow. So I'll talk a little bit about what the collaborative is doing. The collaborative is again, it's an effort led by RMI. It's sort of a spin-off of the ABC initiative in a sense, and the idea behind it is to act as a sort of market facilitation and transformation hub that that drives what we call ABC, advanced building construction, which is this, energy efficient, low carbon, new construction as well as retrofit that has, fast on-site deployment, competitive value profile, appealing to owners and occupants. And the collaborative does this by aligning major stakeholders. So the demand side, the owners and developers, the supply side, which is like the whole value chain, the R&D side, so folks like Nrel, National Labs, and others that we've talked about, and then the market enablers, which are kind of the arm's length folks who kind of set the context for this, the policy, the finance, insurance, utilities, foundations. And the idea of the collaborative is to take these folks who are pretty good at having conversations and talking to each other, but not always that good at actually working together and becoming aligned towards a particular objective. And in our mind, that objective is better, more efficient, lower carbon buildings, and a more vibrant construction sector that's globally competitive. So talking about what the collaborative is going to do, we see some key activities there. There's this idea of focused collaboration. So having some, working groups of actual industry stakeholders that are focused on particular topics that are action-oriented, so that we're hearing from industry, what are your top priorities? What are your top challenges? What are some near-term actions that you can take? And are you willing to actually, take responsibility for driving some of those actions? There's also the idea of just having cross-pollination when you bring people together in a kind of curated environment with certain high-level goals. And then, of course, there's the idea of industry guidance, which is what Nrel and others are working on. And to an earlier question in the chat about characteristics of buildings, one of the other work streams that Nrel is working on is a typology study that will characterize the building stock in certain key segments of residential as well as commercial construction in the U.S. To help guide some of those efforts on creating retrofit solutions. And then, the collaborative is also going to, as this market starts to evolve and mature, is going to help do some matchmaking between supply and demand to make sure that more and more of those projects are actually, under contract and put into the ground or put onto existing buildings. So, we're trying to, be a platform for, like you said, Dave, taking that great work and putting it out into industry, but also having it be a feedback loop so that what we hear from industry can inform the ongoing and future work that's done by Nrel, other national labs, and that's funded by DOE and other government entities.
Love it. Love it. All right. Listen, guys, so I know we have some more to get through presentation-wise. Let's just say hi to a couple people here. We want to make sure we always get to everybody's comments. This is their opportunity to ask, the top dogs some questions, right, where then otherwise wouldn't have that opportunity. So let's just make sure we get through some of these real quick. All right. Oh, G-Pod's in the house. What's happening, G-Pod? Resilience is important. Coming to us from Twitch. I love it. I love it. All right. Peter Molinar. Out of necessity, post-war construction in Europe was largely similar design townhomes and apartment blocks, lending to repetitive retrofit components. All right. Love it. And then go ahead. You're going to say something, Lucas?
Well, I was just going to say this is what I was touching on earlier, that Peter's absolutely right. There's a great diversity in the building stock in the U.S., and that's one of the challenges that we've been looking at from the beginning. And some of Shanti and Ankar's colleagues at Nrel are working on that building stock characterization study that's going to help, to bring some clarity and some organization to what's out there, so that we can prioritize, hey, what are the first pieces of that building stock that we can scale solutions for, and then keep expanding to the other ones.
Yeah, Dave, I also point out that we've got all the climate zones in the United States here, versus some of the European examples have one climate zone that they're designing. They're one building type, one climate zone they're designing around. So having climate zone and building type specific solutions means we just need to be more flexible. It's a bigger effort, but we're tackling it, and it may mean different technologies, right? It may mean when you get a new air conditioning system, it comes along with a heat pump, and that becomes, majority of it. And it's maybe a solar storage heat pump retrofit, and there's minimal envelope work that you actually have to go through. Or you're in San Diego and you don't really care about your 1 inch of continuous extra insulation, right? Because the climate is such that you want to focus more on your hot water, right, and lower cost and lower carbon heat pump based hot water system. So there's every kind of climate zone and building type will have specific solutions that are that we're after.
Yeah, I mean it's a good point, right? What do we have? 9 climate zones? Is that what it is? How many climate zones do we have in the States? Anybody know? Pop quiz.
There's like 17 in California alone.
Yeah, right. Yeah. So, but you're right. You have to look at things in a different way than some of the other countries. All right. Rajat says, how do you plan integrate DFMA with energy efficiencies? Yeah, I mean it's a good point, right? We are.
So, hey, Anko, you want to maybe show? I think I cover a lot of this in some of the specific strategies, but I think when you look at other industries that have industrialized improvements, right? They hire industrial engineers. There's Six Sigma, lean manufacturing concepts we can all pull from, and one of those is to model your process, right, and actually understand bottlenecks, understand critical material flows, understand what your process does and where those issues are, so that if you want to improve it, you can try it in a simulation before you go try it on a factory floor at VBC or other factory partners that are somewhat hesitant to slow down their factory line to try something new, right? And so, Ankar, if you got these videos pulled up, go ahead, jump in and talk some about that cool work you're doing.
Sure. So let's see. So we're talking about simulation, right? And some of this is also related to maybe such a simulation environment can also help address Joel's earlier question about what efficiencies are to be gained with DFMA and digital fabrication process. So here you see it's within the Unity game environment where we are building out the VBC factory kind of in a simulation environment. We're working with VBC on this, and it's a volumetric process. And you can see a human there, which is clearly indicating the mostly manual process that is out there. If you can see things moving around here, right, with the panels. And so something like this in a simulation environment is a powerful tool to first step is to create a baseline. And so let's say we build out the entire factory, right, along with its movements, its daytime scheduling system, its cycle time on every station, how much units is it completely building, and what's the factory layout. And then the back end of this, the code that's running this cool 3D visualization, high fidelity that you see here, is a discrete event simulation model. We are working on it with the professor in Oregon State University, Dr. Joseph Lewis, who is in his PhD students are helping us build this. But what you're looking at here is like, okay, it's a baseline factory, right? Like, well, what can you do with it? The opportunity here is like one of the things, like again, like going back to Joel's question, is like such a simulation environment can be used to effectively see what's the kind of automation that you can introduce to your existing factory line. And so a factory manager or a process manager engineer directly interfaces with such a tool, and you have the ability to introduce a robotic arm and see what it does to your entire lead time of your process. That's definitely one of the use cases. But how we look at it from the energy efficiency side is, okay, we have these identified energy efficiency strategies or that we want to integrate in the factory, or let's say mechanical systems, right, that are, as Shanti was mentioning, like a heat pump water heater, they want to add in here. Now you can look at it in a 3D and start thinking, okay, if I want to go from a centralized water heating system to this in-unit, every apartment size for itself, a heat pump water heater with this tank, where if you do a volume purchasing of it, where you're going to put it, right? So you can and then how is that process gonna integrate with your existing factory line? Another example is the one that Shanti was talking about on aero barrier. So if you have a repeatable station of this aerosol spraying technology somewhere here, you might be concerned about where will it go, how do you introduce it, what will it do to your day-to-day work. Also, like questions like what's the downtime that you need to figure out, like, and all of that as part of the scheduling. You can use this kind of like 3D environment, immersive environment, if you may, to figure that out. Now, that's still in the simulation environment, right? Now, someone has to actually go to the factory, walk around, and actually make that happen. And so we are kind of, that's kind of like the loop that we want to create, that how can we streamline the process of that intervention actually happening. So there is definitely some amount of innovation or moving around your factory layout involved. I want to just include one more thing, that when we create the baseline, we do a great amount of data collection and of the existing factory. And that data collection is more of like a multimodal data source. So it is a mix of cameras, wide angle lens cameras, where we take images and videos, and we run it through computer vision so as to track the humans that are moving around, and the boxes that are moving around, but also have IMUs and other like sensors, rigid body sensors as well, that can give you more granular time stamps of when was this station empty and when was this station gone. And then you feed all of that to the back end of Discrete simulation model, and then create this in the front end of a 3D so that it's easy to interact with. And so again, on a high level, this is like just a platform that you could use for many different things, and one of the use cases primarily that we are building this as part of is to get more and more energy efficiency integrated. Tomorrow, if you want, like if you're thinking of introducing solar PV on the facade and you want to integrate all of that in the factory, such a platform can at least help take more informed decisions towards that, and so it's a decision-making tool.
Yeah, I mean, for sure. Listen, this is why we're on Twitch, right? The gaming world. I mean, if you look at the 3D, the VR, the AR, they have this figured out already. You know, now bringing the data in on movement and people, like they got the movement, but collecting that data on how long it takes somebody to walk from machine A to machine B to hit the button to bring, right? These are the things you can track, and you can keep redefining how the workflow process, begins and ends. It just blows my mind that we're just starting to really get into this now when it's been around for so long.
Yeah, it's easier in the manufacturing industry and also in certain areas in Europe and builders in Europe who have been introducing automation. So when it's like an automation system, like a machine, it's easier to like track movement patterns and everything. The human in the loop makes things really complicated, but that's what we have, and that's what we also want to improve, because we saw the McKinsey report of like the construction productivity decreasing, right? So again, like this is another tool that can help inform that are there people who have this downtime that was invisible earlier, but now you can identify it, and maybe you can get them to do aero barrier, who are just like sitting idle. And so, yeah.
That's right. Hey, well, listen, I say it all the time. Business is easy until people get involved. I guess the same thing with data. All right. Love it. Love it. Love it. So listen, guys, can you believe it? Hour and 17 minutes already. We're really getting into it. All right. Do we have any more presentation left? Did we cover everything you guys wanted to cover on the docs? Yeah. Got the videos covered. So let's go back here and hit some more comments real quick. And then let's talk about the programs and how people can work with you guys in collaboration, what you're looking for moving forward. And then we'll try and wrap it up here in the next 10 minutes. So sound good? All right. Love it. How do you plan to, here you go. How do you, Rajat, coming to you from YouTube, how do you plan to integrate Dfma with energy efficiency?
I think we covered it.
Yeah, I think so. Yeah, on just a one-line answer to that would be like, think it like from like DFMA is a very high level concept, and it depends on the use case and what you're doing. And so like our plan is to, well, if you really ask about the plan, like it is under design, but also like through collaboration and like making it like happen. And so it's almost like seeing and believing. But when it comes to DFMA, the seeing and believing is not just on the product, but also on the process. So it's almost like prototyping it, documenting it, and like, you know, disseminating it in a stage that like people really understand what like you're talking about. It's definitely like if you just do a quick like Google Scholar search of like all the DFMA and energy efficiency intersection work out there, so like barely minimal, and that's what we are up against. But I think it's if you prove it out on a prototype level, I think something Shanti I think we should mention is the shared development platform, right? So Shanti teased the idea of the mechanical pod. So we are at Nrel, we have an HVAC test lab where we can emulate like operating conditions of different climatic zones. And so what we are trying to do is we're working with original equipment manufacturers to basically take off-the-shelf products and actually build a prototype of this pod, right? And so like just seeing and believing again comes like with bathroom pods. It's emerging. We know about bathroom pods, and people are like talking about it. Similarly, like we want to like build this prototype of a mechanical pod with all of its like operating conditions, and that's how you like actually prove that it can happen. And then there are still research questions of like how you scale it up, definitely. But that's where the partners come in.
Love it. Love it. All right. Thanks for the question. Let's do Henry. So it's similar on the same line. So what's DFMA mantra for volumetric? Target energy efficiencies to drive the DFMA logic, or apply DFMA holistically and measure the energy efficiency benefits?
Both.
Yeah, I'd say most of the work that DFMA and volumetric modular that's been done is not around energy efficiency per se. It's around cost. It's around trying to find opportunities for automation. It's about material management, right, and kind of process optimization, and not necessarily around reducing the complexity or reducing the time it takes to install energy efficiency technologies, especially complex integrated ones. I will say that the solar industry has done a great job at thinking about soft costs and increasing kind of the productivity of installing solar, from customer acquisition to permitting to, you know, just the innovation going into the clips and the mounting and the, you know, the time it takes to install a solar system on your roof, right? And, you know, that's because the soft costs in the installation are more than the hardware itself at this point. And so innovation around the process is critical in reducing the overall dollars per kilowatt hour that comes off the solar off your roof, which is what people ultimately care about, not about dollars per watt of what the panel costs, right? And so those same ideas applied to energy efficiency for sure is a lot of what we're after. And so I think it takes folks that are, you know, have some deep energy efficiency understanding from, you know, and the complexities and difficulties and barriers and site installed, you know, your deep energy retrofits and kind of new net zero energy or passive house projects to then go into a factory and really look for those opportunities where their headaches of trying to do this we've been doing this for 20 years, right? On-site construction. How can we use the benefits that come along with industrialization and volumetric modular factory build to address some of those issues? Perfect.
All right, Henry, thanks for the question. AJ from YouTube, curious to hear from an economic point of view, would deep retrofits make sense as at some future point in time we will have a significant amount of renewables in our grid? Thank you.
Yeah, I can take this one. I think there's two answers, or there's a two-part answer to this question. The first part is that we're actually going to see most likely a significant increase in the potential load on the grid, on the electric grid, as we convert conventionally fossil fueled loads to electric, so with the higher penetration of heat pumps, and also as non-building loads start to shift to being electric as well. Think, you know, charging your electric vehicle and things like that. So that's one piece of it, which is if you just replace the current generation with with renewables, you're not necessarily going to cover all of the increased load unless you get some efficiency. And so there is a need from a grid stability and a grid services point of view for greater energy efficiency in buildings and better, smarter energy management just kind of across the board. The second piece circles back to what I was talking about earlier about the benefits of better, more efficient, tighter buildings going well beyond just the energy efficiency part of it. There's the aspects of comfort. There's the aspect of health, air quality, resilience. All of these that have qualitative and or quantitative value to the user, owner, society, all the rest. And because of that, even if you were to convert again all of the generation that we currently have to renewables, there's still a benefit in doing a lot of the work that we're talking about here.
Outstanding. AJ, thank you for the question. All right, two more, and then we're going to wrap it up here. Peter Molinar, other than perfection in the simulated environment, what kinds of anticipated difficulties were programmed into the baseline? Anybody?
Yeah, I mean, the imperfection comes with the human. So one of the things anticipated difficulty is like you look at any ERP system of any builder, right? And you look at all the schedule conflicts, and which is not part of the factory, right? It's outside the factory, but it's all informing how the factory process happens and how quickly you're moving from one station to another, or what's your stock that's just sitting. Like you have wall panels that are just sitting there, but your station is not moving forward. And so within the discrete event simulation, the environment, which is the back end of it, where we can we're kind of like creating these imperfections, introducing them, and looking at what its effect on the lead time or cycle time, and again, like some of them, like one being just like downtime, right? And how do you really know if there is like idle time or downtime, and can you like bring it up front? What happens historically is like the tool is the value of the tool lies when you have enough of these runs so that it becomes predictive, right? It's so somewhere all of this day-to-day data gets like historically like stored, and then you use that data to predict and improve the next day, right? That's where the value comes in. And so I think sooner than later, we want to get this at the hands of more and more factory managers, and especially starting with our partners of our ongoing project. And I think it's just important to have an uncertainty module. That's it. And then the imperfections are going to come along.
Although I can say we weren't able to predict the Windows lead time going, to infinite on certain projects, right? Where you can't get Windows, and there's only so much imperfection modeling you can do to account for that.
Right. Yeah. One bottleneck in supply chain, right? And then you're stuck.
Good old supply chain. All right, last comment, and then we're moving on to wrapping up. One factory is using smart name tags for employees around the factory. Cool. I need one of those around my house for my twins. I get them mixed up still to this day.
Dave, I think for you, like you're talking about the overused words. The other one is digital twin.
Yeah, right. All right, love it. All right, guys. So one of the big things that's happening out there is there's all kinds of money being thrown at this, and different programs and partnerships are being formed, and you guys are looking for those as well. Why don't you guys tell us a little bit about how our audience can help you get to where we need to go? Anybody? Shanti, go. Yeah,
I mean, we've got a lot of insights into how to think about the design for lowering the cost to get high performance out of volumetric modular hotel rooms and apartments at this point, whether it's steel or wood framed. And so if you've got projects or owners or developers interested in hearing about that, let us know. We're happy to share everything we know from at a high level all the way down to the details of how long it's going to take to get to a 0.06 ACH 50 you need for a passive house certification, and what kind of contracts you might need to think about who's responsible for that passive house level of air tightness, right? And that, which is something that the volumetric modular industry hasn't really sorted out yet. Not really any passive house volumetric modular apartments yet out there. And so it's something that the industry is trying to get into. But if you're involved in any of those types of projects, let us know. Happy to let kind of translate what we know into something that you can use.
Love it.
Yep.
Perfect. Lucas, Ankur, you got anything left in the tank to deliver to us? You got a minute and a half.
All right, so I'll try to make it quick. So, advancedbuildingconstruction.org, that's the URL you're seeing in the ticker there. That will tell you more about the ABC Collaborative, which is, again, this effort that RMI is driving that's more market-facing, and it's about bringing together stakeholders. If you go there, you can register for getting more information. We're going to have a public summit. That will be Wednesday, I think it's April 28th. So if you register on our website, advancedbuildingconstruction.org, you'll get information about that and get registration for it. Just taking a step back, I want to say, there's a potential benefit for pretty much every stakeholder that we've talked about today in what we're trying to do here, as long as it's done right and as long as it's done in a coordinated way. So that's kind of the main takeaway that I want everyone to come away with here. We've talked a lot about automation. We've talked about robotics. We've talked about productivity. That doesn't change the fact that there's going to be a lot of people involved here in deploying these technologies and these practices on site, in installing retrofits, and also in working on creating these products in the factory as well. There's a tremendous need with the 140 million or so homes and commercial buildings in the U.S., many of which are going to still be around for decades, many of which are going to need to be retrofitted. There's a tremendous need for good jobs, for good minds, good technology, and the ABC Collaborative is all about trying to bring people together to think about what are the challenges that we need to start addressing and how do we address those. And it's backed by Department of Energy. It's backed by the folks at Nrel, who are a lot smarter than I am. And to Shanti's point, there's a lot of research streams going on in parallel and in the background that are going to feed into what different stakeholders can get out of and take away from participation in the ABC Collaborative and more generally in different programs that are going on with the national labs and with DOE and with RMI's carbon-free buildings practice. So I'd encourage you to get involved there.
I love it. And as you guys can see in the ticker below, also, they need young professionals for research and innovation. And we're not talking to be lab rats, to test chemicals. We're talking housing innovation. So in research. All right, listen, everyone. Thank you so much for being with us today and sharing all of your knowledge. I look forward to seeing the rerun on this. We had a lot of people tuning in: LinkedIn, YouTube, Facebook, and Twitch. Anybody wants to see any of the rest of this, please go to our YouTube channel and subscribe. Gentlemen, it's been a wonderful afternoon spending it with you guys. Thank you so much. Don't go anywhere. We'll come right back to you after the outro. I'm Dave Cooper. We'll see you next time. Bye now.
Thanks, Dave.
Thank you.